Hi everyone, this is the second part of Defender. In this video we get the ship moving. So if you want to keep up with videos in this series and other series and the other videos that I do, then don't forget to hit the subscribe button and the notification bell, and you'll get timely reminders of when those videos come out. But yeah, I think we'll get started after the fade. So here is the scene that we had before. I'm going to create a new camera. I'm just going to make a duplicate of this. I'm going to do Control D to make a copy of the main camera. I'm going to call it player camera. And I'm going to remove cam move because we don't need it on this component here. So I'm going to remove component. And then I'm going to set the position of this to be 0, 1, and -10 is fine. It's basically going to sit above here. So you're not going to see it in the game itself because it's actually sitting above the main camera and the left and right cameras. So this camera is just there so that we can show the player, because I want the player to be independent of the world. I don't want it to move. But I want it to be in front of the world. So I'm going to make the depth of this camera 50. And so by making it 50, it's going to appear as if it's going to be in front of everything else. And then I'm going to add, I'm going to go to PNGs here, and I'm going to add the ship. And I'm going to drag that into there. And the ship is actually 1024 pixels per unit. Point no filter, and I'm going to click on apply, and then I'm going to choose multiple. I should have done that before. And I'm going to click on apply again. I'm going to go into sprite editor, and we have two sprites here, so I'm going to slice it by cell count. So there are two columns in one row. Click on slice, and you can see that we now have two completely separate sprites there. I'm going to click on apply, close that, and then I am going to drag, I think I can do it in just in the one, but I'm going to drag it this way anyway. I'm going to drag this into the scene here, and this is going to start creating animation objects for me. So assets, art, and then I'm going to create a new folder in here called animations. And then this is going to be ship. And I'm going to call this player ship. And player ship, if I go down to the animation window, you see that it's at 12 frames per second. I actually think that's too fast, because if we run it, we should see the player in the front, and we don't because he's not in the scene. So we need to move the player to the scene. So the ship's going to move to -0.3, and then a Y of 1 and 0. -0, okay. Game. Yeah, there we go. Okay, so there's the player there. So if I run the game, you see that we have the player there. Actually, you know what? It's not too bad. I'm gonna leave it as that. So that's the little player ship. So now that we have the player in there, we're going to add some movement to the player. So just gonna drag that over there. So I'm going to create another script in here, and I'm going to call it ship move. And ship move is going to control the movement of the ship. And we need a couple of things for this one. So we need to know the direction that the ship's going, because when the ship moves, it is heading to the left, which is the right that I'm pointing to on your screen. So when it moves to the right, it's going to move to the ship's going to move to the opposite end to give you more space on screen, so that when you're not right up against the edge of the screen, because it wouldn't be fair, because then all of a sudden an alien comes out of nowhere and then kills you. So that wouldn't be nice at all. And then similarly, when you go to the other side, it's gonna flip and do the other thing. You saw it in if you've missed this, go and check out the previous video, and you can see how it works in Defender. Okay, so what do we need to do? We need to be able to flip the way that the craft is going. So if we did something like private sprite, oop, what the heck happened there? Sprite renderer void awake sprite renderer equals get component sprite renderer, and then we can say void update, and then this is just a sort of basic example. We can say var direction equals input dot get axis horizontal. If direction is less than 0, then if the direction is less than 0, we're going to be heading to the left. So we want to flip the craft, because right now the craft is pointing to the right. So we're going to say sprite renderer dot transform dot local scale equals new vector 3, and then it's going to be -1 1 1. Else sprite renderer dot transform dot local scale equals new vector 3 1 1 1. And so when we head in towards the right hand, so we head in that direction, the way that this arrow is going, if we head in that direction, it's going to be facing that way, and if we head in this direction, it's going to be facing that way. So we can see that we've got that. Now when we run this, and if I press the left button, nothing happens. And the reason why nothing happens is, of course, I've forgotten to put the script on the ship. So I'm going to drag across ship move to there. And now, when we run this, and I head off to the left, you see that the ship is now heading that way. And we head back that way, you can see that the ship is heading this way. So we've got this rudimentary look to the game, but you can see, you know, how it's working, or the sort of the basics of it here. So we need to remember where this direction is, because if I'm heading in that direction, if I'm heading to the left, if I let go of left, it just snaps to the right. And I don't want it to do that. I want it to stay facing the way that it's supposed to be facing. So I'm going to create an enum inside here, which is just an enumeration, and it's just a nice handy dandy mnemonic for programmers. It equates to, if you're not familiar with the enums, it equates to a number. So the first one will be 0, the second one will be 1 and 2, and there's other complications you can get down the line, but that's the basic of an enum. And what it means, though, is it means that you're not putting in magic numbers. You're not saying, okay, what was 1 again? What was 2? What did 3 mean? You have it as a word, and then you can recognize that word in whatever language you want to make it in, and you can use that word which will eventually represent a number, to give it some semantic meaning, not syntactic meaning, semantic meaning. So all of that means I can do enum direction, and then I've got no move, left and right. So I want to be able to do, I want to move left or I want to move right. And in fact, do I need even no move? In fact, I don't even think I need no move, because I just need to know whether it's left or right. So when we start, I'm going to have private direction equals right. So we know that it's always heading in the right direction. So that's the sort of start position there. So now what I can say is, I can say if direction is less than 0, instead of having this there, I can say direction equals left, else if direction is greater than 0, direction equals dot right. And then I can do something like do horizontal, and then do horizontal is then going to update that. So that is going to be void do horizontal. And then sprite renderer dot transform dot local scale equals, and then it's going to depend on the direction. So I'm going to call this just scale, and I'm going to say var scale equals direction equals left new vector 3 minus 1 1 1. Otherwise, so this is this ternary operator. So if this is true, then we're going to set it to be this, and if this is false, we're going to set it to be vector 3 dot 1. I think one puts it. I think one puts it in 1 in all directions. Let me just check. Vector dot 1 unity. I think it puts it all in one direction. It puts like 1 on the X, Y, and Z. Yeah, there you go. Okay. Okay. No help there from the the IntelliSense there. And we can get rid of that, and we can get rid of that. Okay. So when we run the game now, and we head off in the right-hand direction, it will do the right-hand direction, and we hand off in the left-hand direction. We let go, it stays in the left-hand direction. Okay. So now what we need to do is, when we're heading in the right direction, that's fine because there's a lot of real estate on the right-hand side of the screen, and that's good. But when we move to the left-hand side, we want the ship to move to the right-hand side. So that's going to require some horizontal shifting, which means we're going to have to know certain bits about the system in space. So, for example, this is minus 0.3, but if I change that to 0.3, you see that the ship is now over on this side here. So we want to basically move the ship to that position in space. So we need another couple of variables in here, member fields. So we're going to have public float leftmost x equals minus 0.3f, and it's good to have these as publics because you can then if your screen size changes, for example, then you might want to change these values. So it's good to have them to be variable. Most x equals 0.3 public float horizontal multiplier equals 1.5. So this is going to be used for our speed component. We could probably call it speed, but never mind. Okay, so that's our horizontal values there. Okay, so for the horizontal, we're going to do a bit of math here, and I got this right in I was doing a test, and I got this right in my test, so I'm just gonna copy it verbatim, which is why I keep looking at my notes down here. But I'm changing it slightly from the notes, so bear with me. It's probably going to go a little bit wrong here, but I like the fact that I've rewritten it as this, for example. This I think we can tidy up as well because this seems a bit too deep. So maybe we can do some kind of mathy type thing there to make that a little bit easier. So yeah, maybe we can figure something out there. Okay, so if the direction is to the right, sorry, if the direction is to the right, we're going to head over to we're going to head the craft over to the leftmost position, and if it's heading to the left, we want to head the craft over to the rightmost position. So we're going to handle that using a couple of if statements here and some lerping as well. I'm not entirely sure if we need these two if statements or if we can just get away with okay, let's write it as is, as I have it here in the test code that I wrote, and then let's see if we can optimize it. Because it's something I think that's missing from the video sometimes is I do something and I just splat it down on here, and then I don't go back and I don't optimize the solution. Excuse me, sorry. I'm not used to talking because pandemic's on and not many people to talk to. So I think that's what I'm going to do is I'm going to do this solution just now. So I'm going to say if direction equals dot right, else if direction, actually it's just going to be else. So if it's the right, then I want to say var target equals new vector 3 rightmost x transform dot position dot y transform dot position dot z. I can already see optimizations in my head. I don't like that because it's going way off the screen there. So that's the target transformation. So then so this is the target transformation to move the ship to transform dot position equals vector 3 dot lerp, and then it's transform dot position. So whatever the current position is to the target, and it's going to target time dot delta time times, and then we have our horizontal multiplier in there. Okay. If transform dot position dot x is greater than rightmost, transform dot position equals new vector 3. Oh, what the heck was that? Vector 3 rightmost transform dot position dot y transform dot position dot z. So whatever the whatever the y and z coordinates are, we don't change them. And then we set direction to be no direction, but I don't really care about that, to be honest. I don't mind this being set all the time. And then we have render flip equals true. So we don't really need that scale then, do we? So this can be swapped out for a flip. And this one here, the target transform, is going to be exactly the same, but it's going to be for the x. It's going to be the same for the leftmost direction, if that makes any sense. So it's instead of going to be rightmost, it's going to be leftmost. So maybe what we need to do is we just have something up here that says var dir, let's call it dirmost equals direction dot left. Then it's going to be leftmost x, but it's going to be rightmost, isn't it? What's rightmost? if I'm heading left, I want to go to the rightmost. Otherwise, I want to go to the leftmost. And then I want to say sprite renderer dot flipx equals direction dot left. So that gets rid of all of this. Boom. Okay. And then dirmost, I don't need any of that. And I don't need that. So I can say dirmost is this, that there. And then I just need to check to see what that, so that's going to be less than for the opposite side. So if I'm heading to the left, if I'm moving to the left, then I want to check to see if it's greater than that, and if it is, move it to there. Otherwise, it's got to be, I've got to check it to be where it's less than that, and set it to be that value. Okay. Well, let's see what we've got so far. So move to the right, everything's fine. Move to the left, and that works okay. Move to the right, it just flips straight across, so that's fine. Move to the left, and it does that, which is perfect. That's exactly what I wanted to do. We just need to fix the right one. And I think that'll be us done. Okay, so I think what I'm going to do is I'm going to say let me make this a function. So if I do function float and this is going to be test extreme equals direction equals dot left. So if that's true, then we're going to take in a what am I doing here? Okay, right? What I want to do is I want to do this. I want to say private bool left extreme. Float pause, and then this is going to take float extreme. So I'm going to say return pause is less than extreme. Private bool right extreme. Float pause, float extreme, return pause less than extreme. So if you're on the left hand, if you're heading to the left hand side, sorry, if you're heading to the right hand side, it doesn't slam you to the left hand side. And then I'm going to say var func equals direction dot left, left extreme, right extreme. Okay. And so it doesn't know what this is, so I'm going to tell it what type this is, which is a function which takes in which returns a bool and takes in two floats. And it still doesn't like that. Is it probably, do you know what it is? It's probably because this needs to be in brackets. No, that didn't work. Why is that not working? Okay, I think I know why. Okay, so that's kind of what I want to do. So I think we're all agreed that I want to choose whatever function it is. It's a comparison function I want to try. But let me do let me call this P E return P greater than E. P E. Why is this not letting me do this? This turn. Oh, for the love of Pete. What am I trying to do here? Why is it not like that? Can I do this? No. Oh, it really doesn't like that. Type this lambda expression and lambda expression. What? You know what? What if I did equals null? Let me see if this works. If direction equals left, func equals left extreme. No, doesn't like it. Why? No overload or left extreme match is delicate. I beg to differ. That's why, because I did it around the wrong way. So that should be bool. There you go. Okay, so now I can do this way. All right, bear with me here, folks. Sorry. So I can now say, actually, you know what? I can clean this up even more. Var left equals direction dot left. So now I can say if it's the left, do this. Do that. Get rid of that. That tidies it up. And then I can say left extreme, right extreme. What? Why don't you like it? Method group and method group. I don't understand what you don't like. I think it's because it doesn't like this. Now, okay. You know what? If left func equals left extreme. And maybe we can just default that to be the right extreme. Right extreme. Okay. Right. So in this one here, we have our leftmost direction. We check to see direction, see if it's the left. If it is left, then we specify that we're heading to we want to move the ship to the rightmost. And if it is right, we want to move the ship to the leftmost. And then down here, we want to say func that that. So we don't want to call this function. We want to call this bounds hit. Let's call it bounds hit. So we'll rename that to bounds hit. So we want to say if bounds hit, whatever the x value is, whatever the most direction it is, we want to set it to be that value. So now we go into here, and we move to the right, everything's fine, move to the left, everything's okay, move to the right, and you see that the ship now moves neatly from one side to the other, and everything is hunky-dory. Okay, so that is our horizontal ship movement, and you can see that when you go through the world, 1, 2, 3, 4, 1, 2, 3, 4. Now, the other thing is, I'm going to mention this just now, but I have this crazy idea that what I'm going to do is I'm going to have like a baddie spawner in each one of these sections. So when it's on this screen here, the 2 screen, then it's going to have an area in here that spawns humans and scientists, the scientists and the aliens, and then similarly for 3 and 4 and 1 and 2 and all that good stuff. Just to keep it neat, and I think that might actually work. That's my kind of plan for that. But right now we need to get the vertical working. So we have our, this is, by the way, I don't know if you can see this, this is my cheat sheet here. This is actually less code than I have down here. So I don't know why this isn't letting me do this down here, but it's fine. I can live with that. And then as for this down here, we can also have a private vector3 float x, and then we can say return new vector3 x comma transform.position.y transform.position.z. Okay, and that will return our new vector3. Oh, that's going to be set x. Let's call it set x. So we'll call this target equals set x. And get rid of all of that. And then this one here is going to be set x. All there. And that clears that up a little bit. And then that makes it a little bit easier to read, I think. Get rid of these. And now when we test it, everything's the exact same, which is what I was looking for. All right, okay, good. All right, so now we need to get the vertical done. Vertical is a little bit easier, but it's still part of this down here. So we've got do horizontal. We also need to have do vertical. And our do vertical is going to check the vertical axis, so the ship movement, the ship's vertical movement. So we're going to say var y equals get axis input dot get axis vertical var offset equals new vector 3 0 comma y times time dot delta time times 0.5 f0. So offset is just going to be the offset from the current position. Transform.position equals offset. Okay. We also need to know the top and bottom extremes. So I'm going to say public float top extreme equals 1.25. Public float bottom extreme equals 0.75. And that kind of puts us roughly here and here. We need to figure out about the radar and other things inside there as well, which we'll do at some point in this project. And then inside our vertical one, we've got to say if transform.position.y is greater than topic stream, transform.position equals new vector3 topic stream is going to be in there, and then it's going to be transform dot, oops, actually let's have one called set y topic stream, else if transform.position.y is less than bottom extreme, transform.position equals set y bottom extreme. Okay. And then we have our, this is going to be the exact same here, private vector 3 set y float y, and this is going to be our y, and that's going to be our x. I mean, it's not really setting it. Potato, potato. We'll check that out in just a sec. Then we can tidy up the code a little bit more. Okay, boom. There we go. We have our ship flying. I think what we need to do is we need to have the ship always moving in one direction. I think Defender does that as well, where if you choose one direction, you basically you're going in that direction. There's no stopping you. Because I think if I remember the controls rightly, there was only a reverse button on the Defender, so maybe we can implement something like that, where it's like a reverse button where you just tap reverse rather than choosing the direction you can go. That's something to look into. But yeah, I think that's it for this video. Let's tidy some of the code up. So we have our privates here, and we have tooltip. The leftmost screen position the ship is allowed. And then we do the same thing for our right. And let's call this horizontal. Wow, I can't spell horizontal. Good grief. Horizontal speed multiplier. And then this one is going to be the topmost screen position the ship is allowed. And this is the bottom. And that's it, I think. Maybe we could tidy something else up in here. But I think as far as the functionality is concerned, I'm good with this. I think this bit here is a bit messy. I think we could maybe try and figure this out a bit better. I don't really like this. Let me bounce hit equals, so if it's left, or if it's right, then we want to do this. Otherwise, we want to do left extreme. But it doesn't like that. Why does it not like that? This seems... Oh, right, okay. Let's call it B. So right, it's going to be... so yeah, it just does not like that. that just didn't work. It's the confusing error message there. Type of conditional expression cannot be determined because there is no implicit conversion between method group and method group. So what if... See, I honestly think it's something to do with this. It's just trying to get this. But if I did... Okay, so what if I did left, and then I said P... No, it's still doing it. E... I think actually, yeah, I've got a funny feeling I might end up having to do like weird casts and things to get that to work. If you know the answer to that, write a comment in the notes below, but I think this is the closest that we're going to get to it just now. I mean, we could probably figure something out. We could probably pass it into another function or something like that, but I think it's good enough to have it in there. I think maybe the set x. Yeah, set x is fine. And then left extreme is okay, but we should probably add a comment around this. Check if the player has hit the leftmost edge of the screen. And then the same thing here, check if the player has hit the rightmost edge of the screen. Okay, and then those ones are self-explanatory. I'm not going to bother with comments against them. Watch this. I'll come back in like 6 weeks' time and I'll be like, oh, what is this? Okay, I think we're done. I think this is good. I'm going to end the video here, and I'll see you in the outro. Well, that was a fun and exciting project. Well, it's still going. It's just the player part of it, but that's the player movement. So we now have the player movement in there. We've tidied up the code a little bit. I've taken my my hundreds and hundreds of line classes there. I don't know if you can see that, and then pared it down so that we don't need to repeat ourselves, because it's one of the principles of software engineering, DRY, don't repeat yourself. And another one is Yagni, which is you ain't gonna need it. So if you don't need it, don't code it, because it's going to be possibly a waste of your time. So anyway, hopefully this was not a waste of your time. What a great segue that was. If you like this, hit the subscribe button, hit the notification bell, leave a thumbs up. If you get any comments about the video, leave them in the comments below. As always, the GitHub repo for this is linked in the show notes below. And thank you all for watching. I appreciate you stopping by to watch this fill of code, and I will catch you in the next video. Thanks again. Bye-bye.